There's a couple of examples here on page 15. The first one is showing two different quadratic graphs. One of them is kind of a flatter parabola, and the other one is kind of a narrower parabola. And you can see that these parabolas cross each other at 2 points, basically here and here. And in between those 2 points, you can see that the flatter parabola is at a higher level than the orange parabola. Now, outside of this region, to the left and to the right, you can see that the orange parabola, the narrower parabola, is at a higher level than the purple parabola. Okay? So basically, this is showing a case. They might ask you, oh, when is the purple parabola higher than the orange parabola? And then you'd say, oh, it happens in the interval -2 to 5, which is what they say here. So this is a type of problem that they might give you. Another problem they might give you is what they call a tangent line problem. The tangent line is a line which touches a curve at exactly 1 point. Like, for example, this is a terrible drawing that I just did. I drew a curve, and then I drew a straight line, and the straight line is like touching the curve at exactly 1 point, and that's called a tangent line. We'll learn more about tangent lines in a future chapter, but that's all we need to know for now. When you have a tangent line which touches at exactly 1 point, one of the ways you can find the tangent line is with the discriminant. Remember how if you have an x-axis and the parabola touches the x-axis at exactly 1 point, that the discriminant is equal to 0? Okay? So, even if you have a, instead of touching the x-axis, if your parabola touches another different straight line that's at an angle, you can analyze it using the same method. What you do is you take the parabola's equation and you subtract the line equation, and the difference between the two becomes the equation of another different parabola. Okay? And then it turns out that when this new parabola touches the x-axis, that is the exact same x value as the point that the original parabola touched the line. Okay? This is kind of mind-boggling. So we're going to work through a few problems here, and then maybe you'll understand it a little better. Okay? All right. So here, this example here, it has a line, and you notice that this line has a k in it, which is actually an unknown number. We don't know what the number is. And then it also gives us the equation of a quadratic. And so basically they're saying, hey, this is a quadratic, this is a line, this is a line, and the line touches the quadratic at exactly 1 point. So it's a tangent line. They're saying, what value does k have to be so that it actually does touch at 1 point? So what we're going to do is, we're going to take the red parabola, subtract the blue line, and then we're going to get a new parabola, an entirely new parabola equation. And then we're going to see when does that parabola have a discriminant of 0. What does k have to be to make a discriminant of 0? Okay, so I'm going to indicate here in the problem where each of these is. So this is the original parabola equation in red. This is the line equation in blue. And so what we're going to do is we're going to set the parabola equation equal to the line equation. We're wondering when those are equal to each other. And then we combine the two together. And so here we've combined the two together all on the left side of the equation. So now we have the parabola equation and the line equation combined into one equation. And look at it. The line equation and the parabola equation combined together actually gives you another different quadratic equation. Right? Except for in this one, it's a little bit more complicated. But basically, you don't know exactly what this value is, but you can adjust it so that the discriminant of this new parabola, which is the pink one, okay, this pink one here, the equation for this new parabola, or the discriminant of this new parabola, If you find out the discriminant of the new parabola is 0, then it exactly touches the x-axis, which means the red parabola exactly touches the blue line. So let's find a value of k, which makes the discriminant equal to 0. So we just make an equation for the discriminant, which is negative b squared minus 4 times a times c, okay, equals 0. And so we find out, oh, what k value makes this equal to 0? It turns out to be it's k equals 7/8. Okay? All right. I know that's hard, but this is one of the most difficult kind of problems you're going to have in the quadratics chapter. If you understand it, awesome. If you don't, then maybe you're not going to get a 7 on this section. But if you want to understand it, definitely come by after school and I'll help you with it. Okay, now on number 2, it gives us 2 problems here. And basically what it says is that each one of these problems has a quadratic and has a line. And it wants to know what are the points of intersections between these two functions. And they ask you to use the graphing calculator to do it. And this is very easy to do on the graphing calculator, although you need to do it a few times to get the hang of it. So we're going to put the red equation in here, which is x squared minus 3x plus 7. And then the blue equation we'll put here is x plus 5. X plus 5. And we're going to graph them. And then they want to know what are these two coordinates here? This coordinate here and this coordinate here. And the way we can do that is we are going to use second calc intersect. If we do second calc intersect, and it says, oh, what is your first curve and your second curve? Well, we only have 2 curves. We have the parabola and we have the line. First it says, is this the first curve, x squared minus 3x plus 7? And we say, yes, it is. And then it says, is this the second curve, y2 equals x plus 5, which is the line? And we say, yes, it is. And then it says, what's your guess? Now here it's really important to put the guess closer to the intersection you want. First we're going to look for this intersection here. Our guess is pretty close to that, so we're going to hit enter. And the intersection turns out to be, and they want to know it with 2 decimal places. So we're going to say the intersection, the first intersection is 0.58. It says 2 decimal places, so it's going to be 0.59. Okay? And the y one is 5.59. Okay. And then the other intersection is going to be, we're going to repeat it, second calc intersect. And then first curve, yes. Second curve, yes. And then it says, what's your guess? We're going to put the cursor close to this line, or close to this point. So that's pretty close. And then we hit enter. And it's going to be 3.41 and 8.41. Okay? So we have found the 2 points we've been looking for that are the points of intersection for the red parabola and the blue line. Now let's do the next one. It gives us two different ones. There's the quadratic, and there is the line. So we'll go back to y equals, and we're going to put the quadratic, which is negative, and use this negative here, not the minus sign, x squared minus 2x plus 4. And then here we're going to put x plus 8. X plus 8. And then we're going to do second calc and intersect. Okay. And, well, according to this graph, there is no intersection between negative x squared minus 2x plus 4 and x plus 8. So no intersection. You can just tell from looking at it, right? Okay. 3a. Now it says, find where y equals x squared meets y equals x plus 2. So we got a quadratic, and we got a line. So if we want to know where they meet each other, and we're going to do it without the calculator, what we're going to do is we're going to assume that the y's are the same and the x's are the same. So what we're going to do is we're going to set the y's equal to each other, so we're going to get x squared equals x plus 2. Then we're going to move everything to the left side with algebra. X squared minus x minus 2 equals 0. And then we're going to factor to find out that the zeros of the equation, the roots of the equation, are going to be x equals 2 and negative 1. Okay? So those are the two values of x in which these two functions meet each other. Okay? And if we want to know the y values that correspond to each one of these x values, we take the x value and we plug it in to the blue line. So we're going to put 2 in there. We're going to get y equals 2 plus 2 is 4. So the y value here is going to be 4. And the y value for negative 1, we're going to put negative 1 in there. We get negative 1 plus 2, which is 1. Y equals 1. Okay? So one of the points is going to be 2, 4, and the other point is going to be negative 1, 1. All right. Now it asks us a different question. It says, solve for x when x squared is greater than x plus 2. Okay. So we know that at x equals 2 and x equals negative 1, x squared is equal to x plus 2. Now it wants to know when is x squared greater than x plus 2. Okay. So one of the ways you could do this is you could graph it on the calculator. So I'm going to put these two lines in here. So I'm going to put x squared, and then the other function is going to be x plus 2. And then I'm going to graph both of them. And you're going to see that this parabola here is the red function, and this line here is the blue function. When is the blue function higher than the red function? Well, when is the red function higher than the blue function? The red function is higher than the blue function on this piece and on this piece. So this piece would be x is less than negative 1. And this piece would be x is greater than 2. So that's the answer, actually. It's going to be x is greater than 2 and x is less than negative 1. There's another, more algebraic way of doing it, and the way you do that is you say, okay, first of all, I'm going to move this over to the side. We're going to get the same answer in a second, but just to put it away, we're going to put it here, okay? And the way I'm going to do it now is I'm going to start with x squared greater than x plus 2, and I'm going to change this into an inequality like, oh, x is greater than 2, or something like that. So, the way I'm going to do that is with algebra. First, I'm going to put everything on the left side by subtracting everything over. So I'm going to get x squared minus x minus 2 is greater than 0. Now I say, oh, I'm going to factor this. So I'm going to put x, I'm going to get x minus 2, x plus 1 is greater than 0, right? All right. And I know that this function here is equal to 0 at 2 points. It's equal to 0 at 2, and it's equal to 0 at negative 1. Okay? What about the interval between negative 1 and 2? I'm going to pick one point, a very convenient point, which is 0, between these two values, and then I'm going to put 0 in here. I'm going to get 0 minus 2 is negative 2, 0 plus 1 is 1, negative 2 times 1 is negative 2. So basically all the values between negative 1 and 2 are negative values. Okay? What if I put in a big positive number like positive 100? Then it's going to be 100 minus 2, which is 98, times 100 plus 1, which is 101. So that's a big positive number. If I put a big negative number, I'm going to get put a negative 100 in there. I'm going to get negative 102 times negative 99. Two big negative numbers multiplied together gives me a positive number. Okay? So basically, what I see doing it algebraically is that if I subtract the red function minus the blue function, the difference is positive on the left side and the right side. So those, again, are the regions where x squared, the red function, is greater than the blue function, which is the linear function. Okay? All right. Now we're going to do one more example that's a little bit more complicated. So I'm going to have this red function here, which is a parabola, and then I'm going to have this red function here, which is also a parabola. Okay? So basically it's saying, first, when do those meet? Okay? And we could do that with the calculator, or we could do it like we just did with algebra. Okay? Since we already did one with algebra, I'm just going to set it up, and then after that I'm going to do it with the calculator. Okay? So what you're going to do is you're going to say, oh, well, this y is equal to this y, so I could just set those equal to each other. 2 plus x squared. Okay? And then I'm going to combine these, put everything on the left side, subtract x squared from both sides, and I'm going to get x squared on the left side only. Subtract x from both sides, I'm going to get minus 2x, and then subtract 2 from both sides, and get plus 1 equals 0. Okay, so this is a quadratic equation, a new quadratic equation that is not the same as the other quadratic equation. And if I find where what the x values are of this, then I can figure out what the intersection points are. Okay, and so how would I do that? I would factor, for example. Okay. It turns out that the factoring here would be x minus 1 times x minus 1, okay? And so there's actually only one solution, which is x equals 1. So the red function and the blue function only meet at one point, and the point turns out to be x equals 1 and y equals, how do we find out the y? We can put the 1 into either the blue function or the red function. But don't put it into the pink function, because if you put in the pink function, you're just going to get 0 and it's worthless. So put 1 into the blue function, for example. Then you're going to get 2 plus 1, which is 4. So you're going to have y equals 4. Okay? Now that we have x equals 1 and y equals 4, we know the answer to 1, which is where do they meet? And the answer is 1, 4. All right. Now we can look at number 2, which is solve for x values where the red function is bigger or higher than the blue function. Okay, so we do know that the places where the red function and the blue function meets is just at one point only, which is at x equals 1. Okay, now we want to know, okay, what about to the right of 1? Is the red function higher or the blue function higher? And what about to the left of 1? Is the red function higher or the blue function higher? And the way we're going to figure it out is with algebra. So we're going to say, okay, let's put everything on the left side. So 2x squared minus x squared is, oh, and then like if we combine these, we're going to get the exact same thing we got before. We're going to get x minus 1 times x minus 1 is greater than 0. Okay, and so let's see. We know that at x equals 1, it is 0. At x is greater than 1, like let's put in 100 or something, we're going to get 100 minus 1 times 100 minus 1 is positive. If we put x is less than 0, like, I don't know, 0, we're going to get negative 1 times negative 1, which is a positive number, so it's positive. So it's positive on the left, it's positive on the right. Okay, so it says when is the red function bigger than the blue function? Well, it's bigger at every single point except for x equals 1. So just the answer is basically x is not equal to 1.